It's time for our last blitz talk of the day. So please, would you welcome Frédéric Sagné.
Thank you. Okay, well, that's a lot of light. I'm Frédéric Sagné, and I'm an iOS developer. I've been working for a French agency in Paris for the last 2 years, and at Lassie in the NAS team for the 2 years before that. And I've been starting my company, which is called Teapot Apps, 2 months ago. And I don't know how many people around here are using core data, like, extensively. Let's wait. Can see it? Yeah. Okay, well, quite a fair bit. Well, I know a lot about core data, or at least I thought I did before I started this TV magazine app. So, principle was you take a TV magazine, you put it into your iPhone, simple. So that's about 100 channels, 8,000 programs. And when we thought about the use cases of this app, we thought, well, when would you want to read your magazine if you had it with you at all times? And that is when you're bored, like in the subway, in the train, on the car, something. So we thought, well, why not make it all offline? So download the whole database so you can watch it when you want to. You would get quite good performance, scrolling and stuff. And we could do a lot of nice tricks, like sorting and stuff that wouldn't be as responsive as we would like if we had used a web service. So I ended up building a very nice web API, synchronization framework, JSON streaming, core data, background stuff. I was quite proud of myself. I mean, 8,000 objects pulling in. You see the table view populate. It's really nice. I love core data for that. That was until I tested it on the device, and it took a whole minute to import on an iPhone 3GS, which was at that time the base model. 1 minute of, like, not really a blank screen, but you really had to wait a minute to really use the app. So that was quite awful. We ran a few tests and narrowed it down to the core data processing. So it took like 2 minutes to download the file and 58 seconds to import it into core data. So again, 8,000 objects. So to give you a little background, here is the model that we used. So we have channels, like the BBC. We have programs, such as Top Gear, and a broadcast which links the two, which is, let's say, Top Gear on BBC at 8 p.m. on Sunday. If you look at the core data schema, it's really simple. I mean, yeah, I did it a little bit simpler than in reality, but you have the channel, the program, and the broadcast, which has a one-to-one relationship to a channel and a one-to-one relationship to a program with the inverse relationships. Otherwise, the Xcode would complain that we don't have reverse relationships. So we run a few other tests, and it turns out when we synchronize the data, first we import the channels, then we import the programs, and in the end we import the broadcasts. And importing a broadcast means creating an object and the two links to the channel and the program. So, well, channel and program took like 10 seconds to import, which is okay. I mean, 700 objects per second. And the broadcasts were like 5 times slower. So, and I couldn't really think about why it would do that. So I went in, optimized every bit of core data that I knew of. I cached object IDs. Well, every possible trick I would hit really a hard wall, like 52 seconds. I couldn't go lower than that. So I fired up instruments, and we can see we are faulting a lot of objects. And that is faulting objects when we insert broadcasts. Why would it fault objects? I mean, it's only creating a broadcast. We know we didn't have that problem with channels and programs. And the only difference between a broadcast and a channel, sorry, or a program is that broadcasts have relationships. So I tried to work on that, and I removed inverse relationships, and that's what we have. So solve the problem. I mean, we had similar performance inserting channels, programs, and broadcasts just by disabling inverse relationships. So to understand why we had such a huge drop in performance, really 5 times slower, I ended up activating, like, you have a debug switch that tells you all the SQLite statements that core data does when it's doing its processing. So I narrowed it down to a broadcast and got the log of that. And we end up with 4 selects, 2 updates, and 1 insert. That is, when you create a broadcast, so you first instantiate your broadcast, you fetch the you fetch the channel and the program that you want to link to. That is by getting object IDs, because these were cached, so you don't touch anything in the database. But we end up actually faulting the channel, faulting the program, and faulting the inverse relationships for both entities. So, and finally, we end up inserting updating, sorry, the program and the channel, and finally, what I thought it just did, inserting really the broadcast. And to understand why it needs to fault these objects, these entities, you have to think about core data as what it really is, which is an object graph. It's not an ORM, it's not an abstraction of SQLite. It really is way more than that. Actually, you have backends like in-memory store or XML backend, and we happen to use the SQLite one because it's the most flexible and powerful and so on. But it didn't start with SQLite. So if you just think about our model as an object graph, when you want to create a broadcast, what you do is you instantiate the broadcast, and you want to link it to the channel and program. So what do? Well, first, you mark the broadcast as to be saved, because you want to save it, because you're creating it. Now you get the channel that you want to link to, and then you take the broadcast, you assign the channel to the broadcast, and you put the broadcast in the array, which is called broadcasts, in the channel. And in fact, you updated the channel because you added an object to its broadcasts array. So you marked it as to be saved. You do the same with programs, and you save programs in the same way. So when SQLite is now the backend of core data, what happens is when you first instantiate the channel, it faults the channel because it has to get the broadcasts array to insert an object into that, and to make sure that the broadcast isn't already in there, to make sure that all the consistency checks, because we have a one-to-one relationship, but in the other way it's one-to-many, and you have to keep this consistency. And actually what it does is it marks the channel as updated. It bumps its version. Every entity in the database, in the SQLite database for core data, has a zopt field, which is like a version number, so that it can guarantee the consistency between different threads and stuff. So, so you really end up saving both and fetching the channel, the program, and the relationships. So core data has a cache, so that can be you can prefetch the relationships to make it less terrible performance. But basic thing is, for core data to guarantee that your object graph is consistent, it has to get this data and it has to update the channel and the program. So, what are the solutions to that problem? First approach is, did I really need to import all that data into core data? I mean, I had 5 days of program, so what I could just do is like import tonight's program as a priority, or download the one that for the channels that your user favorited, or stuff like that, so that I have first a small set of data that I could display, and then like download and import the long tail in a background task. So that's the first approach. That means we are still in the core data scenario. We use all the frameworks tool, and everything looks nice. But not all problems can be solved by that. There are ways where you will have to have the whole database into your app. So the second approach is to disable inverse relationships. But that is that can be dangerous, because now you're kind of disabling the automatic core data processing. That's why Xcode complains when you do that. Because now you have to guarantee that the object graph is consistent when you modify it. Like, for instance, when you create broadcasts and you just delete a channel, core data has no way to tell to nullify the broadcast channel relationship, which means your broadcast now has like a dangling pointer to an NS managed object that's no longer valid. Same thing for the program. So what you would have to do is like make sure when you delete a channel that your broadcasts that link to this channel are nullified, which in fact means fetching all the relationships. So it works, but you have to be careful. But you still have all the core data features for the rest of your model, which is really nice. And the third solution is to go SQLite only. So this is, for instance, a benchmark that we had. I ran the same benchmark for SQLite objects, so performance is way better, but don't forget that this is only storing objects. So you would have to re-engineer all the things that core data did for you, which means getting batch data to put into your table views, managing all the graph, managing the relationships, guaranteeing consistency, and that's a hell of a lot of work. So that's not that's not a lightweight decision to make. So famously, NetNewsWire does it. So you have a nice blog post about that, where he says, well, he tweaked it, and in his case, well, reading RSS is like really huge on data, so he had to do that because performance was really a high point in his app. So it can be a solution, but you really have to think it through because it's a hell of a lot of work. Okay, so that was it. So the presentation and the benchmarks and stuff are up on GitHub on my account, and you should read core data relationships documentation. It's a subset. It's really not that long. It's like 3-4 pages, and I learned a lot out of that. And well, there's the blog post I spoke about, and I'm on Twitter and mail. So the main thing that you want to keep in mind of that presentation is like core data is not simply an ORM. It's not simply an abstraction over SQLite. It's really an object graph that happens to save its data into SQLite. Thank you.